in this many years the population of something will double. You can use the ln of that to estimate. Okay, the doubling time only depends on the growth rate. So if you're investing money, then your doubling time would depend on your interest rate. And they've actually given you the formula here, the doubling time for 2,000 to double from $2,000 to $4,000. If you have 6% interest, your doubling time would be ln of 2 divided by 0.06. Okay, the reason they put 0.06 in my formula is because my interest rate is 6%. Okay, now all they want to do here, there's actually no variable in that formula. And sometimes this question kind of messes people up because they're like, well, I don't know what to plug in for. All you have to do is take that ln of 2 divided by 0.06 and just put that in the calculator and figure out what it's equal to. Okay, and I get 11.55 years. So if I'm earning 6% interest, that's how long it would take my money to double.
Not bad.
Okay, not that bad. You're probably not going to earn 6% interest, but not bad. So it would take about 12 years. Or wait,
no,
round to the nearest 10, so 11.6.
Yeah.
And you guys can figure that out for your own account. If you have some amount of money, you can just take ln of 2 and divide by your interest rate, and that'll give you how long it'll take your money to double.
How would you graph the number 21?
See, on this one they're putting
put in the formula, whatever that is, and to graph it, and it says to graph from x equals 5 to x equals like 4.
You would just put x equals, you would go to your window settings, and you would just put x equals 5 as your x minimum, and x equals 40 for your x maximum. You guys want to try that? She was asking about part C on number 21 where it asked us to graph.
So in the graph part, you would just put ln of x, you wouldn't put a number for that? Or would you?
Yeah, your x is your, you just type it exactly like you see it. It'll
I
understand
can't
the
just go
ln.
back up here.
Yeah, it's just showing them it's like a straight line.
Yeah, that's how I know.
You gotta look at the question and the graph is for 3 years different from that, and you put that number in the first value, and you take your start off. That's how that should be separated.
Thank you.
I think you actually need to put your ln in parentheses. So they want x equals 5 to x equals 40. So I put that in as my x min and my x max on my window setting. Now, I also need to make my y values match theirs. We actually get to the third chart. graph to look like theirs, you need to make your window match theirs. So I want my x values to go from 5 to 40, which is what they told me, and I need to make my y values go from 3,000 to 12,000. Okay, that's what my graph looks like. That. That's actually a very bad thing to do.
What?
To make your axis not start at 0.
I think
Your
mine
axis
should
should
one
always
time.
start. Your axis should always start at 0. It's considered bad form.
I missed that.
Yeah.
Alright, let's go back to what we were talking about, which is the doubling time for investment, number 26 or 25. Last time we talked about what some different words mean when you're investing, like semi-annual, quarterly, bi-monthly. And you need to remember those for question 25. Because if you're compounding a different number of times, then what your doubling time will actually give you is how many periods of compounding it takes to double. Okay? So if I plug this in the calculator, and this one is log 2 over 0.0043. I get 70.007. Now that doesn't actually mean 70 years.
So
Because I'm compounding bi-monthly. That means 6 times a year. Okay? So what that means is 70 compounding will double my money. So to figure out how many years that is, what you want to do is divide by the number of times you're compounding per year. So if I'm compounding bi-monthly, that means 6 times a year, so I want to divide that by 6. And I want to go ahead and use that answer that's already in my calculator and not round it. Okay? So 70, if I'm compounding 70 times, and that's 6 times a year because it's bi-monthly, then it would be 11.7 years, or just 12 years if they want me to round to the nearest whole number. Okay, so you want to go back and remember those words, like quarterly, monthly.
Yeah, I had to do it like 4 times and I finally seen quarterly.
Quarterly, yeah, so
No
you're
wonder it
divided
wasn't
by
right.
4, yeah, that one's kind of tricky. Now, what's the other thing they're doing here that's weird? They are round the value of n to the nearest integer. Okay, this one's kind of weird here, you guys. Let me see what they want me to do here. Round the value of n to the nearest integer.
When I got that one wrong, it actually gave a simplified fraction. A true simplified fraction.
Oh, they gave you a mixed number.
Yeah.
This is the only problem I've ever seen where it'll take a mixed number answer. Oh, I see what they want you to do. They want you to go back to when you do log 2 divided by the interest rate. They want you to round that to the nearest whole number and then divide by your number of periods. So I would round it to 70 and then divide by 6 and then change that to a fraction. That's what they want me to do. So 35 over 3 would be my answer, which is
Let's see what they take it.
2 and 2 is 80. and then you're compounded quarterly, so you're compounded 40 times. If you do it 4 times a year, so you divide that 40 times, and then you do it 4 times a year, it would be 10 years.
Yeah. And I think like, see how you can see like what you're putting in the calculator? Me, I can't.
They already
Like,
wrote the formula for you.
see, like, I'll put this in and then I'll push
Everybody
that
get that
and,
little, anybody have
you know
trouble
what I
with
mean?
that?
Like, so then I'm like, oh wait, but I need to do that.
Log
You guys are
2,
working on different
did
stuff.
you do
Yeah,
log
Have you
2?
guys? I skipped a couple of those, because some of those you just have to plug in numbers. Are you having trouble with one of those?
Rounded is 46. Yeah, 46.
Yeah, I skipped a couple of them because
46.
I don't want to spend a lot of time on
No.
ones where you just have to plug in numbers.
Compound is quarterly. So quarterly is 4 times 4, 6, 5, 12.
Because we also need to talk about earthquakes.
So go 11.5. So that would have to be, make it a copy.
That's what I'm
Oh,
saying. We need to
so
talk
it's
about
11
earthquakes.
and a half.
Alright, so I'd appreciate if you guys could skip the ones that I skipped for now and just wait on those. Because the ones I skipped are the ones where you just have to plug in numbers into the equations.
So we're going to 27?
We do want to talk about earthquakes. Because earthquakes are...
Oh, yeah, this is a hard one. I didn't know nothing about this.
They're not hard. You just have to know what's going on.
I couldn't figure this out.
Do you guys know what logarithmic scales are?
What is it called?
Logarithmic scales. Logarithmic scales are scales that work on the logarithm of a number instead of the actual number. Now, the reason you would use this is because logarithmic scales don't tell you the actual value of something. They tell you how it relates to other values. Okay? So if you have some kind of base, you kind of have to have some kind of base reference point. And then you figure out, like, well, is it 2 times the reference point, or 3 times the reference point, or 4 times, or 2 times above it, or 2 times below it. A good example is octaves on the musical scale. Okay, so like you kind of have like middle C on a piano as your reference point, and then like 2 octaves would mean 2 times above middle C. 2 C's above that. If you guys do music, you know what I'm talking about. So you don't care what the actual frequency value is, you just care, well, it's 2 C's above middle C. Okay?
So basically, the only thing you're looking for is multiplications.
Yes.
How many times?
Yeah.
You're not caring if they're only part one. You're only looking for how many times is it.
So how far above or below is it from the reference point? You don't care like where it actually is. Okay, and earthquakes are another example. So you guys have heard like an earthquake may be measured like 5.4 in the Richter scale. Okay, do you know what that means? What does 5.4 mean?
Bad.
Bad.
It means bad, right?
Yeah.
Well, sort of bad. It's
Well,
not like
the higher it goes up, the worse it is.
the higher it goes up, the worse it is. But what does the actual 5.4 mean? 5.4 what?
It's 5.4 times 0, I guess.
It's 5.4 times the reference point.
Reference point. Okay.
Okay? The reference point is what's called the level 0 earthquake, which is the minimum thing that they would call an earthquake.
That's 0.
Well.
It's called that's what they're calling I0.
Okay, what's
Okay.
it called?
I0. I0 is the level 0 earthquake.
There may be some of an earthquake that they don't actually consider an earthquake in there.
Well, I mean, like, when a train goes by and your floor shakes or something, that's not an earthquake. But there's some point of movement where they've decided this is an earthquake. Okay? And that's the level 0 earthquake.
So I0 is just a reference that they use, and it's always going to be 0.
It's
Whatever
not
they're
equal.
measuring.
It's not equal to 0. It has some value of like, I don't know how it's measured. It's measured in.
Well, if you was instead of earthquake, if you was
forms.
doing the scale on music, it would have a level reference to 0.
Level 0 would be like your middle C.
Okay.
Okay. So the formula for the Richter scale measurement is the log base 10 of the intensity of that earthquake divided by the level 0 earthquake.
That makes sense.
Okay? Now I divided by I0 just tells you how many times stronger it is.
So do we actually have to have the logarithmic inside there?
The log of
The actual log itself, LG. Because I mean it's basic.
yes.
And what is the I in this formula?
I0 is the
That one. But
measurement of the level 0 earthquake.
what would I be here?
I would be the measurement of that earthquake in terms of I0.
Okay.
Let's do the example.
So I is going to be 61,000 or 64,000.
Okay, an earthquake has an intensity of 64,000 I0. So my intensity here is equal to 64,000 times I0. Okay, so they're not telling me the intensity is 64,000. They're telling me it's 64,000 times I0. So 64,000 times stronger than that level 0 earthquake.
So wouldn't that be like 6.4?
So, hold on. So if I want to plug in my formula, I'm going to do the log of I over I0. Well, if my I is 64,000 I0, what's going to happen there? They cancel out, right? Now that always has to happen. I0 has to cancel out because I don't know what it is. I don't have a number for it. So it's always going to cancel out. You're just going to end up taking the log of how many times stronger it is.
4.8.
Is that it?
Yeah, 4.8. 0.617999974.
The log of 64,000?
Yeah.
4.8. Okay, so when they tell you however many times I0, you're just going to end up taking the log of that number. Now what if what if I want to go backwards? What's the opposite of log base 10?
IN. LN.
No, it's not the opposite of
It-
log base 10.
It'd be the square root of it?
Ladies,
It'd be
what's the inverse of log base 10? The opposite of log base 10 is 10 raised to a power.
oh. Okay.
Okay? So if you do 10 raised to the R power, that'll give you the ratio of I over IO. It'll tell you how many times stronger than I0.
Now, how would you put that into a problem? Can you give us an example of this one?
It's probably the next problem.
Yes, it is.
Okay, so the Richter scale of an island earthquake of 2007 was 5.6. Find the intensity of this earthquake as a multiple of I0. Okay? So 10 to the 5.6 power. So the opposite, they took the log of something and they got 5.6. So if I want to work backwards, I need to do 10 to the 5.6 power. No, I don't want to write there. I want to write here. Thank you.
398107. Yeah.
Okay? That's your answer. So that, the 398,107, that's your I over I0. So that tells you how many times stronger than I0.
I got it to work out for yours, but it won't work for mine.
Dang, mine came out big.
So what's your Richter scale on your problem?
5.7.
5.7, so you just do 10 raised to the 5.7 power.
I got 501,187.2336.
Okay.
Yeah,
For the
I
rest of the
rounded it.
nearest whole numbers, so you just do 501,187.
Oh, okay.
Golly, Richter scale 6.4 is big. What would the graph of something like this look like? I'm curious.
The graph?
Because it seems to be growing exponentially.
It increases at a decreasing rate. Like that?
Okay. Why would it be?
Because the difference between like a 2.5 earthquake and a 7.0 earthquake is huge, right? But the difference between like an 8.5 and a 9.5, like 8.5 is total destruction, 9.5 is like total destruction
Plus one.
plus one, you know? I mean, once you get to that total destruction point, you know,
It's already destroyed. Okay.
everything's already destroyed. But like the difference between a small earthquake and a big earthquake is a very big difference in destruction.
So the Richter scale really isn't the measurement of the shaking strength, it's a measurement of the damage caused from the shaking strength.
No, it's a measurement of how many times stronger is it than the level 0 earthquake. I'm just explaining destruction in terms of why you can think of it as decreasing.
I'm still trying to figure out why it decreases, because it seems like it shouldn't.
It doesn't decrease, it slows down.
Well, that's what I meant.
It
slows down.
It flattens out. You get to a point where you can't increase anymore. You can't keep increasing forever. Okay?
I guess.
Once you've already destroyed everything, you can't destroy anymore. Now, what about the question that asked us what the difference between two earthquakes is?
Find the difference in the two values and make that the exponent.
Yep.
So I put that 0.15. 215.
Yeah.
Okay, did you guys hear that? If two earthquakes if you have two earthquakes, the difference in intensity is 10 to the R1 minus R2. Just find the difference in the Richter scale.
You subtract.
You subtract the difference in the Richter scale, and then you do 10 to that number. That'll give you the difference in intensity.
You work by that.
So if you know of two earthquakes and you're going to figure out how many times stronger is one than the other. Same question. Okay, so I've got number 30. I've got an 8.69 earthquake and a 7.3 earthquake. How many times stronger was the first one than the second one?
So what would the formula then be?
So what I want to do is I want to first figure out the difference on the Richter scale. So do 8.69 minus 7.3. Oh, now you want to write. Okay. have
3
to-
9?
Yeah.
I got 2 9.
Should be 3, 9, right?
Oh, you have 8.
Oh, okay.
You've got 5, 9 now.
8 3 9.
Okay, now if you want to find, if you know the Richter scale and you want to find the intensity, you do 10 to that power.
So I put 10 to the power of 1 3.
That's it.
Can you do my number on yours?
So I get 24.55. And round to the nearest 10, so 24.6.
Yeah.
Or
Sorry, I thought
24.5.
you were doing
What's with rounding there? I don't think anyone's paying attention.
Can we have a break?
Yeah, let me talk about one more thing. Well, yeah, you guys can take a break. Let's take a break. 12:45?
Sounds great.
Can we get back to the screen where you were?
Finally.
Learning about the different.
This one?
Yeah. Okay.
Which one was you going to start working on? That.
We're just going to talk about pH and decibels, so that's, those are